Hi guys, this is Vineet, and in this video we will discuss about transactions. So what are basically transactions? So transaction is basically a block of code, or you can say a unit of work that manipulates the data in some way, and it can also possibly manipulate the data structure as well, like table structure for example. Basically, every transaction must have four main properties, and these are known as asset properties. So the word asset stands for atomicness or atomicity. Let me complete it. Okay, so A stands for atomicity, C stands for consistency, I stands for isolation, and D stands for durability. So let's discuss the properties, these four properties of transactions in detail. So basically the SQL standards dictates that or says that a transaction should support these these four properties. So first property is atomicity. Our transaction should be atomic. So basically, what do we mean by atomicity of transactions? So by atomicity we means that either that transaction complete in its entirety or does not take place at all. So either it should complete in its entirety as a single block of code, or it should not do anything. And this is not a default statement in default behavior in SQL Server, but the SQL standard says so that this should be the property of a transaction, but by default this property is not and this is not the default behavior of SQL Server. Maybe it can be turned on by setting some options, but by default this is not the behavior of SQL Server to support atomicity. And in order to achieve the atomicity in error handling code must be introduced. So in order to implement the atomicity part of transaction in SQL Server, this can be introduced via incorporating error handling code in the SQL Server code. So we can write error handling code in SQL Server in order to implement atomicity. Second property is consistency. So what this property denotes regarding transaction. So a transaction should be consistent, which means it should transition the database from one state to another, one consistent state to another. So what do we mean by consistency? By consistency we mean a transaction should be consistent and it should transition the database state from one consistent state to another consistent state. Let's come to the isolated property or the isolation property, which indicates that a transaction should be isolated, means that intermediate inconsistent states. Let me highlight this quickly, 1 second. Means that intermediate inconsistent states of the data are supposed to be visible only to a transaction that made the changes or that are making the changes. Okay, let me that are making the changes. Let me make. Okay, so what do we mean by isolation? A transaction should be isolated means that any of the intermediate inconsistent states which can occur during the execution of the transaction. So basically these are the states of data, the intermediate inconsistent states of the data, and these intermediate inconsistent states should only be visible to a transaction that are making the changes, but not to any other transaction. Okay, so basically it is trying to say that a transaction should hold a lock, some kind of lock onto that particular data, so no other transaction can change that data at particular time. this particular transaction is working on that data. So at the time when this transaction is working on the data, no other transaction should make changes to the data. We can control the isolation level of the transaction at either the session level or query level with the set transaction isolation level option. So the isolation level of the transaction can be set either at the session level or the query level. We will discuss about this in detail in one of my other videos. So what do we mean by basically session? So whenever we open a new query by clicking on the new query button, this whole tab refers to a session. So this is a complete session. It has a session ID as well associated with it. So if you look at this number in the bracket 521, this refers to the session ID number. Session ID number is 521. So we were talking about the transaction isolation level. So it can be isolated at this complete session level or at individual query level. We'll discuss about those two options later on. For the time being, let's move on to our next option. And the last option or the last property of a transaction should support. A transaction should be durable. The last property is durability. So a transaction should support durability. Means that when we commit a transaction and get the acknowledgement from the database that the transaction is committed successfully, then we can rest assured that transaction changes are durable. So basically, what do we mean by durability? Durability states that once the transaction is committed and we get the acknowledgement of that commitment from the database that the transaction is committed successfully, and we should be sure at that time that transaction changes are durable, means they are persistent or finalized. This means that the changes can survive the crash of the SQL Server process. So once the transaction is committed and we got the confirmation from the database that the transaction is committed successfully, we should be sure at that time that these changes are finalized, and even though after the commitment of the transaction and after the receipt of acknowledgement, even if the SQL Server crashes at that point, such a result should hold. I mean, the final changes made by the transactions once it is committed should hold, even though there is a crash after the committing of transaction. Alright, let me review this last line again. This means that the changes can survive a crash of the SQL Server process as a result of a power failure event. So any changes that are committed to the database should be saved, even though there can be a crash after that commitment. Alright, so we have so far we have discussed about the 4 properties of transaction. Let me move on to next slide where we are working on some transactions. So how to work with transaction. So basically, in order to start a transaction, we use the word begin transaction. We use the begin transaction statement in order to mark the start of the transaction, and to end the transaction and commit its work, we write the keyword commit transaction. We use the commit transaction statement. Let me make these bold. So to mark the beginning, we use the statement begin transaction, and to mark the end of transaction, or to commit the whatever changes we have made in the transaction, if we want to commit those changes to a database, we write the commit transaction statement. And in order to abruptly roll back the transaction in between, or to end our transaction and roll back its work, undoing all of its changes, we use the rollback transaction statement. So these are the three statements we usually come across while working with transactions. So first is begin transaction, second one is commit transaction, and third one is rollback transaction. And there's also a function, or we can say a variable, a global variable, which we can query using the select statement to get the active transaction count or the open transaction count. That global variable is at the rate run count. It basically gives you the count of current open transactions. So right below is a diagram of the orders table from the Northwind database. Again, it has a order ID as a primary key and various other columns, and it joins with the order detail tables, where the order ID key from the orders table act as a foreign key in this table, and this table also hosts the product ID key as a foreign key from the products table. In this example we will use both of these tables. Alright, and we will use the following code to add a new order to orders table in Northwind database. So let's quickly review this code. Let me copy this code and review this code inside SQL Server. Let's copy this complete code. So let me go ahead and copy it in here. Okay, the code is now copied, and let me adjust the slider of this Object Explorer window. Let me make code in multiple lines. Alright, so that it should be more visible to you. Okay guys, so we are in the process of reviewing this code. So in the first line of code we are using the Northwind database. So here Northwind is selected. If we use this statement, Northwind database gets selected. We are setting the exact abort no count options to on, and we had discussed about these statements in our previous videos. So if we set the exact abort option to on, it will not leave the transaction open. If we encountered any error during the execution of a transaction, it does not leave the transaction open, and it will abort the transaction as well. And setting the no count option to on omits any messages that it displays after the execution or during the execution of the query, that how many rows are affected, etc. Here we are marking the starting of a new transaction with the begin transaction keyword, and here we are declaring a variable, an order ID or a new order ID you can say, which is of integer type, and below is the code to insert a new order into the orders table. So we have taken orders table from the Northwind database, and we are using the following columns: customer ID, employee ID, order date, required date, ship via, freight, ship name, ship address, ship city, ship postal code, ship country. And we are putting values for these particular columns as wine 5, and we are putting certain dates, and we are putting certain values inside that particular table. And we are setting the an order ID variable, which we have declared before, with the scope identity function, so which basically gives us the new the last primary key value that gets saved in the orders table, which is the order ID, new order ID generated. Alright, so we can fetch that value using the scope identity function. and we can print at this time, we can print the new order ID, the value for which is stored in the order ID function. So we are adding added new order with order ID, and we are casting it as variable character type because this is integer type here. So we are casting that variable as varchar because we are outputting a string, that's why we are casting. So this is the concatenation operator, the plus sign. So we are putting this line added new order ID with order ID, and this will put the value for this an order ID which is stored in this variable. And after that we are printing the transaction count, which can be which we can get by at tran count variable. This is a global variable, so we are casting that global variable as varchar 10, and in the last we're putting a full stop using the concatenation operator, and this message will get printed in the message window after the execution of code. So far we have inserted one particular row in the orders table, and now what we will do, so that particular order must have some order details which will go into the order details table as well, so which was the second table that I was showing to you in the screenshot. So whenever we have any new order, the details for those order, like the order ID, product ID, unit price, quantity and discount, this information should go to order details table whenever we add a new order. So let's look at the code. So as soon as the row is inserted into order table, this message gets printed, and immediately after that we are entering the order details for new ID into the order details table. So for that we are using insert into statement. We are taking order details table, order ID, product ID, unit price, quantity and discount column, and we are putting values. For order ID we are putting the order ID variable. The value is designated during this particular statement to the order ID variable, and rest we are putting product ID as 1, unit price as 10, 1 as the quantity, discount as 0, and we are putting basically three order details. So the customer has ordered for 3 particular products, so those are coming in order detail, and each of these products have the same order ID number. And in the last we are printing added order details for order ID and added order details for the new order, and at this time we will check the transaction count again, and after that we will commit the transaction. So this whole is a single transaction unit. So during the execution of this transaction unit, the value for the tran count should be 1. So let's execute it quickly. So it is giving me that there is invalid syntax near the order ID and order ID, so I think we need to put commas along with that. Now I think we can execute the code. So again, invalid column quantity. So let me check what is the actual column. So quantity is the actual column instead of QTY. So let me quickly make changes to the code there, and this is quantity, not QTY, and we have selected this. Okay, let's execute it again. So we are getting an error. The insert statement is conflicting with the So basically this constraint is getting violated, which is foreign key orders customer, and this conflict occurred in the database Northwind. So I think that this particular wine entry should already be there, so let me make a change to this. So okay, basically a foreign key constraint is getting violated, so I think we do not have any wine customer in the customer ID table. So check let's check what all values do we have in the customers table. So select top 100 star from customers. We can select, it will give us the customer IDs. So instead of wine we can take this ANATR is the customer ID. We can take this. So I'm substituting wine with this. So I hopefully this code will execute now. So yeah, it executed. So we see that the transaction has printed. This is a new order ID. New order ID generated 11085, which is the new primary key for orders table. And during the execution of the transaction count was 1, which was printed through this message. So at this point it was within the transaction, so transaction was open, so open transaction count was 1. And the other time the transaction count was printed is in this second statement, which is within the commit transactions before the commit transaction statement. So at this point the transaction count was still 1. So after the commit transaction statement is executed, the actual transaction count is 0 only after that. So we got these details. Alright, so we have successfully executed this transaction, and let's go to the section in Notepad. Okay, OneNote, sorry. So we have ran the above code and see what order ID and messages we got. So what we got 11085 as the order ID, and these are the messages we got the completion time message, etc. So basically we have executed 2 insert statements within this code. The first insert was inserting values into the orders table. The second one was inserting values into the order details table. Alright, these were the 2 insert statements that we had executed, and these 2 insert statement was within the begin transaction and commit transaction block. Both of these insert statements are within this begin transaction and transaction block, and if any of the insert fails, either of the 2 insert fails, the complete transaction will get rolled back. If any of the 2 insert statement fail, maybe due to any reason, the transaction will roll back in its entirety, and the execution of code will abort. So if any of the in case any of the 2 insert statement fails, the complete transaction will get rolled back. So this is known as atomicity property. So the complete work gets rolled back, so it works in its entirety. And what do we mean by that? For example, if we run the same code as above, and now with the invalid order details, like discount is greater than 1, which is basically a constraint violation, and we will see that even first insert will not take place due to complete transaction getting rolled back. So again, this is the same code, and with little bit of changes, and like order details are a little bit different. So let's only change the customer ID at this point, and during this process we will tries to violate one of the check constants, which is already defined on the discount column. It cannot be greater than 1. So let's do that. So we will take another customer. So at this point we will take alpha key, ALFKI. So instead of ANATR we are replacing it with ALFKI. Rest of the detail we are keeping it as same, and the next order ID should be 11086, I hope. And here we are trying to violate the check constant. So let me write violating check constant. So this is for the discount column. Let me show you where this check constant is defined. So if we expand the Northern database, and if we goes to tables, and the table is order details, so if we go there and if we expand the constant section, so here we see a constant which is defined on a check constant which is defined on the discount column. We can take a look at this constant. So let me see if we can check the property of this constant. This is the default constant. So here the check constant is getting violated, so I need to check this. So if we modify this constant, I've just right clicked on CK discount and selected the modify option for this constant. It will provide us the details of this constant. So let's wait for it to come. So yeah, it has come. So it has opened us a box. So here we are seeing the check discount constant, and here is the expression defined for it, where discount column value can either be greater than equal to 0 or less than equal to 1. It cannot go beyond that. So this is the check constant defined, and if we set 2 as the value for this check constant, the new order ID, even though first of all it will generate the order ID after it puts the data for ALFKI in this particular table, it will print the new order ID. But after that, if we check that new order ID in that particular orders table, it should not be there, because in the second insert statement this will cause the error, because the check constant is getting violated, so the complete transaction will get rolled back. So let me go ahead and quickly run this transaction. So I have executed it. So here we got the message that insert statement conflicted with the check constant CK discount, which we had discussed few minutes back, and the conflict occurred in the database Northern table DB order details column discount. So here in the first statement we see that a new order ID is generated. So ideally the row should be there with the order ID 11086, but in case this should not be there, because the complete transaction got rolled back. So even the entry inserted into the orders table will get rolled back. So if you look at the orders table, select star from orders. If we look back for the previous order ID, it should be there. So let's check for this order ID first, where order ID equals, and let's put this value. So it's 11086. Copy this, put it here, and let's try to run this statement. It will not yield us anything because that insert is rolled back, so we haven't got anything. And if we look at the previous order which we got in one of the previous transaction that was completed successfully, this should be there. So yeah, we can see a row for this. So yeah, we got this point that if two insert statements are there and one of them fails due to any reason, the complete transaction will get rolled back, even though the changes made in the first insert statement will also get rolled back, and this particular row will get removed. Alright, let's move on to our notes. So execution of above transaction will cause check constraint violation as discount greater than 1. This will cause whole transaction to get rolled back, and even the data in the first insert statement will not get inserted into the orders table just we saw. I had just shown you. So we have verified and the code, and we looked at the error messages we got after executing above code. We also checked whether the rows with the new order ID gets inserted into either orders or order details table. So we had just checked for the orders table, not the order details table. Let me go ahead and copy this, and this was the old order ID, so I had to check both in order details and order tables. So let me check order details. Let me make D capital, order details. Okay, this is correct now, and let's execute both of them. So yeah, the previous order ID have details both in the orders table and the order details table, but if we check the last order ID, let's quickly change it, we will not get any of the details in either of the tables for order ID 11086. So both the tables are empty. So we have checked that whether the rows are inserted into either orders table or order details table. Alright, and in order to get the constant details on any of the tables, we can execute this code, execute this stored procedure. So this is a system stored procedure, sp help constraint, and here we are getting want to know about the constants defined on the order details table. So instead of going graphically over here and modifying the constant to check its what the constraint is defined as, or if we want to check the expression, we can use this particular stored procedure, which is exec and then sys. What is the stored procedure? Let me check quickly. Help constraint, which is sp underscore help constraint. So this is a system defined stored procedure, and we need to give the table name. So table name is order details. Okay, and let's execute it. It will show us the detail of all the constants defined on this table. So yeah, if we look at this particular first row, this is the check constant defined on column discount, and the expression is this: discount should be greater than equal to 0 and discount should be less than equal to 1. Alright, so make a note of this statement. This is useful in getting the constraint details defined on the table. Let's move back to the notes. So we got the output. Here the expression was defined for check constant defined on the discount column. So in our above code, we have defined the transaction boundary. So this is the transaction boundary. This is the end of boundary. This is the start of boundary. So these are known as transaction boundaries, and in this code we have specifically or explicitly have defined the transaction boundaries, but most of the times we do not explicitly write the keywords or statements begin transaction and end transaction. And what happen in those cases, let's check. So if we don't specify the transaction boundaries, SQL Server uses the autocommit mode, where each individual statement is considered as a separate transaction. So if we take our previous code, there were two insert statements. So those two insert statements will be executed as separate transactions if the transaction boundaries are not defined or marked using the begin transaction statement or end transaction statement. If we don't define those boundaries, the SQL uses the autocommit mode, where each insert statement was treated as a separate transaction, as if it is preceded by begin transaction statement and followed by a commit transaction statement. Individual statements are atomic, means a single statement either completes in its entirety or does not take place at all. For example, if you execute a statement that deletes 200 rows from a table under autocommit mode, and if the statement fails before completion, say after 20 rows were deleted, SQL Server undoes the change. So basically it is basically telling you that even each individual statement, if we not mark the boundaries, works as a transaction. And it is giving us an example. So if we have write a statement to delete 200 rows from the table using the code as delete top 200 from orders. If we execute this statement, and during the execution of statements, if a statement fails after deleting the 20 rows of data, the entire statement will get rolled back, and SQL Server undoes all the changes it had made. So either we are saying that either all the 200 rows will get deleted or none at all. The type of statements that are considered as transactional statements. So what are transactional statements? So it basically includes the data manipulation constructs like select, insert, update, delete, truncate and merge, and also it includes the DDL constructs or statements like creating, altering, dropping tables, and some of the DCL statements like grant and revoke. These are considered as transaction statements or transactional statements, you can say. These are transactional statements. Assigning values to variables and modification of data in table variables are not transactional operations. So basically it is saying that if we assign any value to a variable, even if it is a table variable, does not come under transactional operations. And if we perform these operations in a transaction, they are not ended up rolling back. So assignments does not get rolled back if the assignments are made to the variables. In the above example, it is not a good idea to use. So the above example, we are referring to this code which we had just executed, this one. So if we take this example, it is not a good idea to use autocommit mode. So we had not used the autocommit mode, we had marked the boundaries using the begin transaction and end transaction statement. But if those boundaries are not marked, transaction will work in autocommit mode, because under this mode, because the first insert statement that adds the new order in the order table and the second insert statement that enters data into order details table are considered as two separate transactions. So if we had not marked those boundaries using the begin transaction and commit transaction keyword, these two insert statements are treated as separate transactions, right? So if the first statement succeeds and second fails, then we will ended up with an order without the order details. Alright. So why autocommit mode is not useful? If we had used the autocommit mode for running the above code, and in this case the order gets inserted into the order tables, but this particular second insert statement failed, so it will not roll back the row inserted into this table if we had not used these boundaries. Alright, So auto commit mode is not useful here because both the insert statements are interrelated to each other, because adding order also involves adding the order details as well into another table. So in the above example, it is not a good idea to use auto commit mode, because under this mode the two insert statement, one that inserts data into order table and second that inserts data into order details table, are considered as two separate transactions. In case where the first transaction succeeds and the second one fails, we ended up having an order without any order details. This is just we had discussed, and we have a code to demonstrate this. So let's run this code again with the same example ALFKI, and here we are violating the check constraint, and let's remove the begin transaction keyword and the commit transaction statement. Now if we run this code, basically what it will do, it will generate a new order ID, put that order inside the order tables, but a failure will occur in this insert statement and it will not insert any rows for that particular order ID, the newly generated order ID in this table. So let's check this. So I'm executing this code and it has resulted in violation of the check constraint, and a new order ID was generated. So let's check for this order. So for this order ID 11087, we will find the rows in the orders table but not in the order details table, because the insert operation which inserts the data into the order details table had failed. Alright, you got my point. So we have data in the orders table but not in the order details table, which is not good. So that's why we need to mark the transaction boundaries. Marking transaction boundaries are useful. So let me go ahead and quickly remove the 11087 order ID from the orders table. So it has removed now, and let me go back to the notes. So we just saw that running the above code will kill the transaction. We got the new order ID 11087, and we checked this by running this following statements. We had checked this for 11087. Row was there in the orders table but not in the order details table. So, and these nodes I had checked for another example. So in my practical work today, we had checked for 11087 order ID. Now we do see that row with order ID 11087 exists in the order table, but there are no corresponding details for order ID 11087 in the order details table, and this is basically we do not want, and therefore it is important to perform both the activities in a single transaction and no two separate transactions. So we need to mark boundaries for this transaction using the begin transaction and commit transaction statements over here. That would be the ideal practice. So I think guys we are done with this video, and in this video we have told about the properties of a transaction, which is basically asset properties: atomicity, consistency, isolation, durability. We have discussed these properties in details. In addition to this, I've also discussed about working with transaction, how you can run the code inside the transaction block with the markers begin transaction and commit transaction, and we had discussed few examples of the transaction, and we had shown you check constraint violation as well in one of the transactions. So guys, do like this video and post your comments on my video, and do subscribe to my channel, and I thank you for watching this video. Have a nice day.